All right, well, hello everyone. My name is Doug Stevenson. I am a developer advocate with the Firebase team. I am happy to be in Denver today because this is my first time here, and I understand there are a lot of breweries in Colorado, and the craft beer scene is off the hook. I don't, do people still say that? I don't know how to sound cool, but I've been enjoying trying different things, and definitely a craft beer fan. So I stay here through Saturday, so I'm going to be looking for things around and about to try. What is there to say about Firebase? Who here already uses Firebase in your app anywhere? Okay, we got a couple. Well, okay. So for those of you who aren't familiar with Firebase, it is Google's mobile development platform that helps you build apps quickly without having to manage infrastructure. Firebase has a reputation for being a backend as a service, so its roots before it was acquired by Google was real-time database, authentication, and hosting. So people were building apps using those components, not having to manage infrastructure, not having to manage servers. That quickly grew into, at I/O 2016, we launched 15 different components, and now there's performance monitoring. Now there's cloud functions, so you have sort of a serverless backend to write code. So I'm not going to actually focus on the backend as a service. I'm going to focus more on the tools that it provides to help you boost the quality of your app. And that, a lot of people don't think about Firebase as an app quality thing, but we're kind of thinking it is, because we're providing some things that very directly and very materially can help you boost the quality of your app. So let's talk about one-star ratings. If you're an app developer, you probably know one-star ratings are like the worst thing ever, and they're often not helpful, right? People put stupid comments in there, and they're just, they're just not helpful. And they hurt the perceived quality of your app because every one-star rating is essentially dropping your overall rating, right? So you want to prevent this. And it turns out in the Play Store, 50% of all of the one-star ratings mention something about stability or crashes. So obviously, a crash in your app is an invitation to your users to just go into the Play Store and rate it 1 star and maybe even uninstall it. So we're all too familiar with this problem. So the thing we're trying to do initially, at least during testing and development, is prevent these things from happening. Like obviously, you don't want to have an app that crashes. You want to do everything you can so that when you hit that publish button, everything goes smoothly. So you need something during test and development. Now the problem is there are a lot of Android devices out there. Everyone knows that, right? That there's tens of thousands, something like 13,000 different Android devices that have been identified by the Play Store. It's pretty hard to get a hold of each one of those and make sure your app works well on all of them. Like that's kind of a silly proposition to think that you should obtain and use all of these things. You probably have 1 or 2 devices that you use at your desktop, but for the most part, it is taxing to try to collect all of them and test on all of them. So one thing that Firebase provides is Firebase Test Lab for Android. So you can think of it like a device farm in the cloud where you can use that you can use to test your apps. So send your APKs and your test APKs to Firebase Test Lab. It'll make things a lot easier because you can test across, I think there's like 30-some devices now, and they're adding new devices all the time. There's both physical devices and virtual devices. And the virtual devices often offer versions of Android that are not released yet. So if I recall correctly, Android O was available in Test Lab as a virtual device before it was actually, before it would actually hit like real devices. So what do you get with Firebase Test Lab? Well, if you send your APKs up for testing, you will get, obviously, logcat. In fact, you'll get a logcat from the moment that the device booted. So the very first line is going to be like Linux starting up, right? And if there's any crashes, you'll see those in there. You'll get a video of your app running, so you can sort of scrub along and see exactly where things went right or went wrong. You'll get screenshots, and the newest thing that we offer is performance metrics. So you can see the history of the CPU performance, the memory usage, and network ingress and egress as your app executed over time. So we're pretty excited about this one. So how many of you here do any testing at all with like Android, instrumented tests? Okay, okay, half you. Okay, so that's good. So I'm not going to say anything that'll surprise you right now. Instrumented tests in Android are specific to Android. So when you hear people talk about instrumented test or instrumentation tests, they're talking about very specific to Android. And they focus on the user story. So as the user is using your app, when you write an instrumented test, you're pushing buttons, you're scrolling recycler views, you're entering text, you're submitting forms, you're logging people in. It's the kind of things that users would actually be doing in your app. And you write them using a framework, an instrumentation framework. So we offer Espresso and UI Automator. So those are managed by Google. We're deprecating support for Robotium. So Robotium is actually an instrumentation test framework that it's technically an instrumentation test, but it's a little bit flaky, so we're actually in the process of deprecating that. So if you have tests written in Robotium, I strongly encourage you to move to Espresso, which is far more well supported and sort of less flaky. Espresso is really good for testing within your app itself. So actually just pushing buttons and scrolling lists and doing things like that. Espresso has sort of the first class support. UI Automator is special because you can test between different apps. So if you want to interact, if you want to launch another app, a system app, or launch settings or something, you can do that in UI Automator. You can actually mix and match them. So you can write some things in Espresso and some things in UI Automator. It all works in the same general framework. But take a look at those if you haven't already. Now, instrumented tests essentially operate as an extension on JUnit. So if you know JUnit testing, you know how all of the annotations work, you know how JUnit 4 does its business, instrumentation tests do the same thing. These extensions come from something called the Android Testing Support Library, so ATSL. This is maintained by Google. It has a ton of useful things in there for testing your app. And there's a code lab as well. So I actually found out about this recently. If you're new to testing altogether, go through this code lab. You won't have to worry about testing your app. You'll actually test some other app. You'll go through the motions of creating a new test, running it on an emulator. If you can run it on the emulator, you can also run it in test lab, and I'll talk about that later. So when you write an instrumentation test, you'll end up with something like this. So this is testing an activity, and we know it's testing an activity because there's a rule up here that indicates we want to test an activity called notes activity. So this rule actually will take care of instantiating the activity, send it through its onCreate, onStart, onResume, and all that. And then it will run through all the annotated test methods. So here what's going on is we're finding a button called Fab Add Notes, and we're going to perform a click action on it. Then we're going to look at a text view and see if it's actually displayed. So we're going to check if this view matches the displayed state. So this is kind of a fluent API, meaning you're kind of reading it kind of like English a little bit. There is a fair amount to learn here, but I found it very valuable just to be able to learn how to express these tests and write them out effectively. So there's another kind of test, there's local unit tests. So if you're a longtime Java developer like I am, you know that when you do unit testing, you're testing one class at a time, one method at a time, and they're running fast on your computer, right? So you push the test button and all your tests should execute fairly quickly. And it is focused on individual, like line-by-line code, whereas instrumentation tests are testing user interactions. So I think it's actually kind of helpful to have both of them. But when you're doing unit testing, you have to figure out how are you going to do dependency injection? So, if you go back to the days of like spaghetti code, right, where you have, one class is instantiating another class, which instantiates another class, and so if you want to test that first class, you're effectively testing all the other classes underneath it. That's, fairly bad software architecture. It's very worthwhile to learn how to use a dependency injection, and then once you get your dependencies into a class, you can mock them using an object mocking framework such as Mockito. That seems to be the sort of the de facto standard. So I like local unit tests. And if you have them both in your project, you end up with a structure like this. So under source Android test, that's where your instrumented tests go. If you under source test, that's where your local unit tests go. And they're typically segregated like this because local unit tests run on your machine. They can run on your machine. They don't depend on Android infrastructure. Whereas your Android instrumented tests obviously only make sense with an Android runtime behind it. Now I like having both of these. They both serve different purposes. The problem is you don't want to necessarily run them separately. I'd prefer to run them together, and I'd want to run them on test lab. So the reason why you'd want to run local unit tests on test lab is you're actually writing Java code, and there's a JVM on your machine that knows how to interpret it, but the JVM that's running on your machine is quite different than the one that's running on Android, right? On Android, you either have Dalvik or you have ART. And theoretically, the bytecode should execute the same. But if you're using APIs that are not supported on different versions of Android, you could run into crashes that way. So I actually find it useful to run local unit tests in test lab on actual devices in various versions of Android. So one of my tips to you is run your unit tests along with your instrumentation tests. And you can do this with a little bit of Gradle magic. So you can configure your Android test source set to include your unit tests. Once you do this, now when you build your instrumentation APK, it'll contain all of your unit tests in addition to your instrumented tests. And then when you send that up to Test Lab, now it'll run them all together. The thing is, if you're using some form of object mocking, so like Mockito, well, now you have to add a couple lines to make sure your normal test compile has Mockito and your Android test compile also has the Android version of Mockito. And they're slightly different because Android, just because of the way it works, it requires a little different way of mocking objects. It's not the way the normal JVM works. Now, another tip I have, and I think this is super helpful for finding problems, is to enable strict mode when you're running in Test Lab. So if you haven't dealt with strict mode before, basically what it is, it's an API in Android that lets you say, I want to do something drastic in response to bad practices, right? So typically in Android, you're not supposed to read and write on the main thread, like no I/O on the main thread. You don't want activity leaks. There's this whole slew of things that are bad practices that aren't necessarily that bad, but could be that bad. So you want to use strict mode and turn that on. You want to turn on strict mode, and you actually want your app to crash if one of those things happen. That's a really strong indicator that you've done something wrong. But you don't want to do that in production, right? You don't want to ship an app that has a mistake that causes the app to crash if it doesn't have to crash. So you probably just want to run it in certain circumstances. So in my apps, I'll do something like this. I'll write a method called enable strict mode, and I'll arrange for this to be executed as early as possible. So that would either be like in a content provider that gets initialized right away, or in your application object. I prefer content provider. And then I'll ask, I have another method, and I'll show you that later, should strict mode be enabled? And if it is enabled, I want to detect all the problems, like every single problem that could be a problem. I want to log it, and I want the app to crash. And then if you run this on Test Lab, then you'll see errors show up if you violate the strict mode problem. So traditionally, if you're trying to decide if you should enable strict mode, I've always done that in debug mode. So when I'm developing on my desktop, I don't care if it crashes if I violate strict mode. I can see it right there. I'll fix it right there. But the problem is, how do you make this run on Test Lab but not in production? Well, it turns out Test Lab has a way of detecting if the app is running in the Test Lab environment. So you just add a few extra lines of code. There's a system setting that you can query. Now you can run it in either debug mode or in Test Lab. Now you have sort of like this greater coverage across all the devices that you're testing on. Now, there's one weird problem that I actually learned about earlier this week, is that if you enable strict mode during a content provider or in your application object, Android will actually disable it right before the onCreate of the next activity. So if just because you're enabling it doesn't mean that it stays on. This is a bug in Android, and you can read about it in Issue Tracker. Basically, there's a workaround for this where you enable strict mode as soon as possible, then you post another enable of strict mode on the handler. So what this is saying is, as soon as possible, enable my strict mode again, which will happen to occur after the onCreate of the first activity. It's kind of a hacky workaround, but this will fix the problem of strict mode being disabled prematurely. Now, you might be thinking, okay, testing is a lot of work. I don't want to learn Espresso. I don't want to have all this extra source code. Like with unit testing, you're writing at least one line of code for every other production line of code, right? And often more. Your unit tests will often be larger than the code itself. And that's just a matter of fact of testing, right? If you don't have time for that, and I understand, I don't have time to double my code load. It doesn't make sense. That's okay. If you want to do testing anyway, Android Studio has a feature called the Espresso Test Recorder. So in the menu, under Menu, Run, you go to Record Espresso Test. This will write Espresso code for you. It'll actually wait for you to interact with your app and then write the Espresso code that matches what you did. So if you fire this up, you'll get a dialog. So the one on the left is a dialog that's waiting for you to use your app, and then I have an emulator right next to it. So you can kind of see as it goes along here, it's recording what you're doing. So in this test, I hit a fab, and then I did a new I asserted that new note is being displayed, then I tapped another thing, typed some text in there, tapped another thing, and then I asserted that the new note was created. So this is effectively a use case, right? I created a new note, I wrote some text into it, and now I want to know that it appears on the next screen. So this is pretty handy. And you can take this code, like this will appear in a class, in a method that's already ready to run. And you can take it, you can modify it, you can copy it, you can learn from it, you can do whatever you want. But the important thing is you're not writing it from scratch, right? And that's kind of the hard thing. Once you have something generated for you, it's easier to work with it. So that's pretty handy. But you might be thinking to yourself, I don't even want to have tests. I want to test. I want the benefits of testing, but I don't want to write it at all. It turns out TestLab has something for you as well. So there's a test called a robo-test. And what robo-test does is it automatically crawls your app, trying to, it's kind of like the same way that Google would crawl your website, right? It's clicking every link, pushing every button. In some cases, if you want, entering text into form fields. You're basically getting something for nothing. You're doing testing. You have this test agent testing for you. You haven't instructed it to do anything, but it's still doing things, which is pretty cool. So with a robo-test, the only thing you need is an APK. Now with instrumentation testing, you actually have two APKs. You have your app, and then you have the APK with all your tests in it. Here you just upload one APK and be done with it. If you have a Google authentication part of your app, like if it pops up that screen asking you for your credentials, it'll automatically log in. But if you have some sort of form-based login that requires a username or password, you can configure Robo to do that as well. So you can actually put in Android resources of names of text views and the text that you would want to put into it. So that helps Robo bypass login screens or perform searches or basically crawl your app deeper than it would without doing this stuff. And you can also configure the maximum crawl depth. So if you find that Robo is like rabbit holing in one part of your application and not at the sacrifice of breadth, you can configure these things. You can also say how long you want the test to go. Now, because this is hosted in TestLab, the algorithm theoretically improves over time because the team is always working on it. So yeah, definitely look for updates. They're trying to make it crawl faster. They're trying to make it crawl more effectively. They're trying to make it more intelligent about how to perceive widgets and perceive scrolling things. And there's a lot of effort that's going in behind this because we recognize that developers just don't want to write tests. And I kind of get that pain as well. So you could actually use a Robo in combination with instrumentation testing if you want. So let Robo generally crawl your app, and then maybe you have a very few specific cases that you write specific tests for. So that's a valid use case as well. And when you run a Robo test, you'll get an additional test artifact called an activity map. And this is actually like a graphical display to see how Robo actually descended your app. So you get to see screen to screen to screen how it navigated. If there was a crash, now you can see what led up to that point. And I think that's pretty cool, right? I mean, you get to see effectively, how Robo gets to, how it perceives your app. Now, you might be thinking to yourself, well, I'm building a game. Robo doesn't know how to work a game, right? Games typically take over the whole screen. They have their own widgets. They have their own UI. Robo doesn't know anything about that. Robo only understands Android widgets, so text views and buttons and recycler views and stuff like that. But if you're building a game, Robo is just going to launch it and say, oh, I don't see anything there. I mean, its vision is very limited. And instrumentation tests are kind of hard to write for building games as well because you have to hone in on a pixel and try to touch it, deliver a touch event to it, and that's just kind of a pain. So there's a special kind of test in TestLab now called the game loop test. Is anyone building a game in here at all? No? Okay, well I will just blow right through this. This won't be very interesting to you if you're not building a game. So if you're like me, you grew up in the 80s, you went to arcades all the time, and you watched games play themselves, right? You had what's called attract mode, and console games have this too. So it's a common thing for game developers to have this kind of attract mode. So you can build an attract mode, which is basically scenarios for your gameplay. It's driven by a series of Android intents. So in your manifest, you declare how many tests you want, the activity that matches a filter that it'll launch, and it'll deliver intents. Your activity launches, goes through the scenario, finishes when it's done, then it turns around and launches another activity. So it's basically a harness for you to write your own sort of open-ended tests. As a result of that, you'll also get performance, an additional performance metric for that. So it's frames per second. So your games should be rendering at 60 frames per second. This is special for Surface View, actually. So if anywhere in your app you have a Surface View, you're going to get a performance metric along with that as well. There's a code lab if you want to do it. There's a sample app. It's actually written in Unity. So Firebase actually supports Unity. So not only is it a good example of how to use Firebase on Unity, there's also code labs that will help you figure out how to do this sort of game loop testing. And so at the end of that, you're going to end up with this self-playing game. a series of scenarios that look something like this. And then this is actually a screen of what the performance output looks like. So for games, you probably can't see this, but there's a graphics row, and you can see that it mostly maintains 60 frames per second, but there's some dips in there. So that gives you some sort of indicator of like where you need to maybe optimize your rendering, or maybe your game engine's doing something funny. Maybe there's too many sprites on the screen. But that's what performance output looks like. You also can't see this, but there's a vertical bar in there, and you can actually use that to scrub along and look at the point in the game or in your app where there's obvious performance problems. Now, to get these tests up into Test Lab, you can use the Firebase console. So the Firebase console lets you upload an APK. So like I said, with RoboTest, you just upload your app APK instrumentation tests. You have a regular APK and a test APK and game loop. Obviously, you have your game APK. Now, you can also run a test through Android Studio. Now, this is one of those, another one of those hidden features of Android Studio. If you're familiar with run configurations, there's a run configuration that allows you to target Firebase Test Lab. So now when you run this run configuration, it'll actually deploy to Test Lab as long as your Android Studio is logged in and attached to your account. You can run it on as many devices as you want, so you can configure your matrix. So this is handy if you're just trying to fix one problem and you want to run a single test on a single device in Test Lab, or maybe multiple devices on Test Lab. You can configure that any way you want. Now, the thing for people who are really serious about testing is using the command line. Now, this command line is pretty ugly, right? There's a lot of text there. I wouldn't recommend this for day-to-day use, but the G-Cloud command line is actually super valuable because now you can integrate your tests into a continuous integration server. So some of our biggest customers are like American Express and Walmart. They're running thousands of tests with like every check-in, right? They're constantly testing. And the way they do this is when their CI server finishes a build, they'll use the G-Cloud command line, submit that to Test Lab, then look at the results and fail the build if something fails in Test Lab. And there's a pretty good community support around Test Lab. So Walmart actually came up with an open source project called Flank, and it'll shard test very effectively. So one of the problems with running normal tests is they run in serial, right? They run one after another. And that means your tests kind of take a long time to execute. So what Flank does is it'll break apart your tests and run them in parallel on Test Lab as fast as possible. It sort of figures out this optimal route. So check that out if you're a heavy tester. And if you use Circle CI, there's integration into Firebase Test Lab as well. So check that out if you're a Circle CI user. There's one other kind of test that's in the Play Store console. So if you publish an Android app, there's a new thing called, well, it's not that new, but there's a thing called pre-launch report. This pre-launch report, and you have to opt into it. So you go to the pre-launch report, opt in. It doesn't cost you anything at all. But what happens as a result is if you publish your app to an alpha or beta channel, the first thing it will do is go send it off for a 5-minute robo test. And the results of that will appear in the pre-launch report console. Now, this is pretty handy. You could think of this as kind of your very first beta user who's telling you basic things like, did the app even crash on launch? Like that's kind of an endemic problem in Android apps is that, some devices just crash right away, and you kind of want to know that, right? It's kind of like your first beta user. You can also think of it as a smoke test to see, did the APK I just upload, is it sane? Like, does it make sense? So you can use the Play Store as a way to get some initial quick testing. And billing for Firebase Test Lab, for paid projects, you're doing per minute billing. I think it's rounded up to the minute. Virtual devices are $1 per device hour, and physical devices are $5 per device hour. Again, if you're a heavy user, if you're a heavy tester, you're probably willing to pay this, right? It's not that much. But for those of us, myself included, who have personal projects who I don't want to, I don't want to pay this, there's actually a fairly generous free tier. So at no cost, you can run 10 tests per day on virtual devices and 5 tests per day on physical devices. Now, this is pretty handy, just even to run maybe a nightly test, right? So if you have a continuous integration server, you say, do a nightly build at midnight, take that APK, send it up to Test Lab. You can do that without paying indefinitely. So give that a shot if you haven't already. Now, okay. So everything we've talked about right now is during test and development, right? So use Test Lab, do testing. That's a great way to ensure the quality of your app. But when it comes times to publish, and I don't know if you all have apps out there, every time I publish my app, I get a little anxious about pushing that publish button, right? Because you're like, okay, is that APK? Is it the real one? Like, and you're wondering, is it going to be okay? When are my users going to get it? There's that sort of anxiety about this. The fact of the matter is, problems always exist, right? Someone's going to make a mistake somewhere down the line, so you need to know about that, right? So you probably need a crash reporting tool, and everyone in here probably understands like crash reporting is a pretty basic thing. Firebase does offer Firebase crash reporting. It's part of the console. It's a simple SDK. It requires no lines of code, but if you want to add some lines of code for logging, you can do that. Now, if you've been paying attention to Google News, you probably know that Google acquired Fabric not long ago. And Fabric offers Crashlytics, which is another crash reporting tool. So now Google has two crash reporting tools, Firebase Crash Reporting and Crashlytics. You might be wondering, well, which one do I choose? Like, how does this even make sense? Is one of these going to go away? And you'll even notice that when you go to the Firebase console, look at crash reporting, you're presented with both options. And the text is really small here, but basically it's suggesting Crashlytics is the go-to recommended crash reporting tool. That said, you can still use Firebase Crash Reporting. It is pretty clear that we see Crashlytics as the future of crash reporting, but there are some reasons why you might want to choose one or the other. So Crashlytics is generally more robust, so it has Unity support, NDK support for Android, issue searching, there's webhooks, so if a crash happens, you can register a webhook to receive that information. On the other hand, Firebase Crash Reporting is tightly integrated into the Firebase ecosystem, so whenever your app crashes, it'll generate an analytics event, and that will end up just like all the other analytics events, so you can do funnel analysis, and you can do some diagnostics, and you can export to BigQuery and query your crashes that way. Conversely, analytics events will show up in crash logs. So if there's a crash that happens, you get to see all the analytics events that led up to that, which is super helpful for getting context on the crash. Like, it's just good to know what the user was doing up to the point of the crash. Now, we realize that there are advantages to either one. In the future, whatever we provide, whatever the final solution is going to be, the Firebase team is basically not going to pull the carpet out of either one of these solutions. Like, we will provide a good migration path going forward. So you can choose one or the other and be assured that the future is going to be relatively easy for you. We don't want it to be hard to upgrade. That said, on Android, you can actually use both at the same time. There's actually no limit to the number of crash reporters you can use. And that has to do with the way that uncaught exception handlers work in Android. So I'll do a technical detour. And the reason why I'm interested in this is I actually wrote the first version of Firebase Crash Reporting, so I actually have a fairly deep knowledge of how crash reporting works. So in Android, you register something called an uncaught exception handler. This is Java too, so both Java and Android do the same way. So you register an uncaught exception handler. This is an interface with a single method, uncaught exception. And it gets dealt the thread and the exception that caused the crash. So you can deal with it there. But notice that my handler here is actually receiving another uncaught exception handler in its constructor. And it's calling through to that. It's calling through to that uncaught exception handler's method. Now you think, why would you have to do this? Well, that's just the way that uncaught exception handlers work. They don't work like listeners. You don't listen in on a crash. You actually register a handler, and that handler needs to call through to the one that was there before. So what you're supposed to do is grab the prior handler and then wrap it or pass it to yours so that yours can do whatever it needs to do and then call through to the other. So you're essentially setting up a chain. Now, there's actually no obligation for your code to do this. Like, you can set a default exception handler and have it not call through to the prior, but that's not a very well recommended practice. Now, this is actually what happens, and I'm sure everyone is familiar with this dialog. This is what happens when an Android app crashes and the default exception handler does this. It actually throws up that dialog. It logs some stuff in logcat. All that stuff happens. If you don't call through to the prior, this will not happen. That dialog box will not show up. And you'll think, oh, great, no more force close dialogs. But I wouldn't recommend that because the app actually won't crash. It'll still keep running, and it could be in a terrible state. Like, it could be out of memory. And then the user's going to be like maybe more pissed off than they were if they had just crashed normally. So always call through to the prior. Now, I think this, just as an aside, I think this dialog is kind of funny because it's telling you something fairly bad happened, and your only option as a user is to think that it's okay. Only one button, this is okay. I don't think this is okay. I wish they would, like, maybe change the text of that button to say, that sucks or something. Like, yeah, bummer. Ooh, sorry about that. Yeah, it's not okay. Let's be honest, it's not okay. Yeah, I could get, well, yeah, I mean, this is just a screen capture, but I should do that for the next talk, my proposed solution to this. So anyway, so we have test lab when you're developing. We have crash reporting in production to find out problems. And hopefully if a crash happens, that will feed back and you can create a test in test lab, test it out there. So there's a good cycle there. But there's one more thing that, that high quality apps need to be concerned about, and that's performance. So I've noticed that when I build an app on a fast office network, on a cutting edge device, generally not too concerned about performance. It's always going to run pretty fast because, you know, like I work for Google, like Google networks are fast, Google servers are fast, like everything's fast all the time, so you generally don't have to worry about it. But your users are going to be on slow networks, on low-end devices potentially. So their perception of the quality and speed of your app is going to be very different than yours, right? And so how do you manage that? Like how do you get to know that? Well, there's another interesting statistic that when people leave 5-star ratings, and this is again collected from the Play Store, when people leave 5-star ratings, 60% of the time they're either mentioning speed, design, or usability. Now, Firebase is not going to help you with design or usability. That's kind of up to you to manage. But we can help you with speed. We can help you understand how your app actually performs. So the first tool you might have already used to understand the performance of your app is systrace. And systrace is a desktop app, and you can see it has a very detailed information of what your app is doing. So you can see what CPUs are doing. You can see, down to the method level what's being called. This is a great place to go to get all the details of how your app is performing. It does have some advantages, which is the detail. Like the level of detail can't be matched. And you can set up custom traces. So if there's a particular part of your app that you want to focus on, you can do that as well. However, this isn't always the best tool to find all of those little performance problems that your users are seeing. First of all, the app runs slow, right? So when you hook systrace up to your app, it's painfully slow, right? So you can't really test indefinitely. It's just not a workable situation. You typically have to know what you're looking for. So you run the app up to the point, then turn on systrace and capture just that little bit of data because you know there's a problem there. You can't just sort of randomly run it or sample throughout time. It would just be too much data to sift through. And you can't collect data from the wild. So only connected devices work with systrace. So basically, this is a development-only tool. Now with Firebase at I/O, we just launched Firebase Performance Monitoring. So, and this is in beta, but we haven't had any, no one's been complaining about it yet. It's still kind of, it's very, I won't say, it doesn't feel like it feels like it could be more robust, and the team is working on improving this over time. So if you want to join the beta and give us feedback, we actually do value your feedback a lot. We want to know how we can make it more helpful for you. So with Firebase Performance Monitoring, this runs in production. This is running in your app, on your users' devices all the time. It's constantly collecting data and sending it back for viewing in the dashboard. It has negligible overheads, right? So it's common sense to say, I'm concerned about the performance of my app, so if I want to measure it, I don't want to cause performance problems. Like the team's tried very, very hard to make sure that the overhead is negligible. So you shouldn't perceive any difference in performance. There are automatic and custom traces. So the SDK, once you integrate it, is going to collect some things automatically without you even writing a line of code. That said, you can write custom traces, and there's an API for that. We'll also automatically collect HTTP traffic. So all of the outbound calls that your app makes using URL connection, Apache HTTP client, or OKHTTP, those seem to be the three most commonly used HTTP libraries, we'll capture all that. We're basically collecting metrics, and I'll tell you a little bit more about how that happens. But the core concept here for performance monitoring is a trace. And a trace, very generally speaking, is a report for a period of time with a well-defined beginning and end. Basically, either automatic or manual, there's just a beginning and an end. So nominally it has a duration. So that you can use this to time a segment of code, right? So you set up a trace, a beginning and an end, and you get some report on how long that's taking. But as part of this report, you can add counters to it. So you can use counters to indicate performance-related events. So like, I recommend doing things like cache hits and misses or dropped frames or something like that. You're basically just associating a name with a value, and I'll tell you more about that later. Now, the automatic traces, and again, this is no coding necessary. All you do is integrate the SDK, and you're going to get these for free. We'll measure the app start time, so cold start time. That would be from the moment that the user touches the icon on the screen. Well, not that exact moment, but a cold launch is basically from the time of, well, actually, I have another slide for that later. We'll measure the amount of time it spends in the foreground. So you can think of that as long as there's an activity in the started state that the user's looking at, that's time in foreground. We'll also measure the time in the background. So when the user pushes the home button, the activity gets stopped, it's not visible anymore, we'll measure that as well. So app start has a very specific measurement. So what we'll do is we'll inject a content provider into your app. During its on-create, we'll measure that time. That is the time that app start trace begins. And then when the first activity goes to its on-resume, meaning the app is fully interacted with, or is fully able to be interacted with, that's when it ends. Now, this is a very, it's a very simplistic way of measuring app start time. Now, the fact of the matter is you might want something different than this. And I was at a startup before called Pulse.io, and we had a number of clients who were very interested in specific metrics about how their app launch was going. So one measured their app launch time as from the moment of launch to when their home screen was fully populated with all the images visible, right? That's their gold standard for understanding how fast the app launches. Because they have a very image-heavy UI, and if it launches but the images aren't there, that's not full. That's not complete, right? That's not the full thing. So you should write your own trace if you want something different. Now, counters, I mentioned before, are basically associating performance-related events to a trace. So here, I'm just sort of illustrating that you can counter up for cache hits and misses. You can count dropped frames if that's helpful. Basically, what you're doing is you're associating a string count value to a trace. So the string is the name of the counter, and the value, you typically increment it. It doesn't have to be like by ones. It can be by anything. But you're typically incrementing some value over the period of time for that trace. Now, my opinion is that it's typically better to measure ratios than absolute values. So say for a moment, you were measuring cache hits but not cache misses. Now, what would you do with a number of cache hits? Like, how would you act on that? I mean, knowing how many times a cache hit happens is completely dependent on how much your users are using your app. If you measure cache hits along with cache misses, well, now you have a ratio. You know how often your cache is being hit or not. And if you don't measure this, how would you know how effective your cache is? But absolute values can be helpful if you want to compare similar counters between traces. So I have an idea for pseudo-automatic traces. So I'm going to go through this quickly because I have like 10 minutes. But one idea would be to use activity lifecycle callbacks in Android to create a trace that maps to each activity. So activity lifecycle callbacks, the way they work is they are able to track the activity lifecycle for all the activities in your app. You kind of listen in on that. So what I would do here is start with the singleton pattern. Then when an activity is started or stopped, record a new trace and associate it with the activity in a map somewhere. So every time you start an activity, you have this trace that's going on. Every time you stop an activity, we'll remove that trace. Actually, yeah. And then you want to expose an API where you can get the trace associated with an activity. So in your code, you would reach into this activity lifecycle callbacks. And if you wanted to add counters to that trace, you can do it with this API. I would initialize it in a content provider. So I'm going to blow through this super fast. Get a hold of an application object. Register activity lifecycle callbacks with the instance of that from the singleton. And if you want to use it in an activity, what you would do is reach into the singleton instance, get the trace that corresponds with the current activity, and then do stuff with counters in that. So now you have all of these traces for all of your activities in your app kind of for free, right? You don't have to write this code over and over again. And you just reach in, grab the trace if you want to do counters with that. Now, you might also be wondering, how do I even think about what to trace? Like, how do I have a strategy for what things are useful or what things are not useful? And I would actually recommend using Android Vitals. So Android Vitals is a relatively new thing. I think this was launched in the Play Store at I/O. What it does is it captures crashes and ANRs and now performance-related events with your app actually as it's running in production. So it'll capture slow rendering. So that's jank, right? If you have a scroll that's not going at a nice 60 frames per second, that's jank. It will record frozen frames. So if a frame sticks for 700 milliseconds or more, which is pretty excessive, right? You'll get a record of that. And any wake locks that are stuck. So a wake lock could indicate a battery performance problem, right? Wake locks keep the device alive for time, but if they stay woke too long, that's kind of a performance problem. So now you have ideas for things to measure in your app. Performance monitoring will automatically capture HTTP transaction metrics. Like I mentioned before, you'll collect response time, which is just the time from the moment of the invocation to the final byte being received. That's the total response time. Payload size in bytes. Success rate, which is defined in terms of HTTP status code. So at 200 type responses are obviously successful. 500 types are errors. Now you can start to see how your app, is the server causing a problem? Is the network causing a problem? You kind of get a sense of where your API calls are failing and how often they're failing, and maybe even how bad they're failing. And there's an interesting feature in the dashboard where it'll do URL pattern globbing. So this is very helpful if you're backed by a REST API. So you know how REST APIs have a very structured format. What we'll kind of learn, it will look at all the transactions and learn your structure and wildcard in there. So if you have tons and tons of users, as you should, right, you don't want to measure each one of those URLs separately. You want to glob them together because they're all probably doing the same query. So now you get this sort of aggregated view of how your APIs are performing. And for each one of these APIs, you'll get a breakdown between app version, device, country, OS level, carrier, and radio. And so now you can start to break down, am I, doing badly on a certain version of API? Am I having poor performance on a particular carrier? And we've seen this before. I've actually received feedback from people who say, for whatever reason, their app performs poorly on a certain carrier, and that actually helps them diagnose problems. Now, you might be wondering how this works. How can we capture all of this data without you writing a line of code, right? And this is kind of interesting to me because this is some of the work that I did at Pulse.io of how do you instrument an app to record all this information. Well, it turns out it uses bytecode manipulation using a library called ASM. So ASM lets you look into a class file, symbolically break it apart, rewrite it, and dump it back out. So we'll look for things that look like this, right? So if you've written a line of code that takes a URL and opens and calls open connection on it, we'll look at that and we'll turn it into something slightly different. So you'll notice now we're injecting this Firebase perf URL connection .instrument, and we're passing it the HTTP URL connection that came from open connection. Now there's a decorator in there. That's the big secret, right? So we're basically returning you a slightly different URL connection that behaves exactly like the one that you originally were going to get, but it's been decorated with performance monitoring. So now we're able to record the times of things and look at the payload size and all the good stuff that you want to see in the dashboard. But again, you don't write any code. We're essentially writing it for you during the build phase. So in order to get this in your app, you obviously have a compile dependency, but that only gets you the SDK parts. That doesn't get you the runtime or the build time instrumentation. And in fact, you can't instrument a code at runtime. At runtime, the APK is locked, right? You can't do anything. All your classes have already been converted into DEX. That's set in stone. So what we do is we have a plugin that will ask you to apply on your build.gradle. And that plugin basically listens in at the time of the build, right after compilation, but before dexing. This is a sweet spot where you can look at all the classes and make changes to them. And it turns out Gradle offers something called the Transform API. And this Transform API is essentially what gets invoked between that compile phase and that dex phase. So this is where ProGuard lives, right? ProGuard lives in this space because it's going to look at all your classes and make changes to them. This is where performance monitoring lives as well. So that's performance monitoring. I have a few more minutes. There's one more part of Firebase that could be thought of as a app quality component, though it's not technically, and that's Firebase remote config. So this is basically a very sophisticated set of key value pairs that you configure in the Firebase console, and they get distributed to your apps. Your app is sort of like receiving these updates, these configuration updates. Now, some of the things you can do with it are plan in-stage rollouts of new releases and quickly back off that release if it has problems. So how do we do that? In the console, we're going to create a new parameter using cool new feature, and the default value is false. So you're basically shipping a configuration that says no one should be using a new feature of mine. And then you add a condition for that. Let me go back. If you click add value for new condition, that'll take you to a page where you can set up a condition where this value could possibly change. So what I'm going to do is create something called is cool new feature active. And it's kind of hard to perceive this, but I've selected in this dropdown use random percentile, less than equal, and then over there 10%. So now what I'm doing is saying 10% of users should be seeing cool new feature. So when they use the remote config API to pull this configuration parameter, 10% will see true and 90% will see false. So now I can enter that value. Is cool new feature active is going to have the value true. Everyone else is going to see the value false. When you publish this, you're going to have this configuration set up in your dashboard. So in the dashboard now, you can modify that condition. You can go in there and say, I don't want 10% anymore. I want 20%. I want 100%. Or I want 0%. Like maybe there's a problem. I want to cut it off for everyone. And in your app, all you would do is get the Firebase remote config instance and ask it, are you using cool new feature? And that'll return a Boolean. So now you have the ability to remotely control your app, right? So if you want to publish a new feature, put it behind a remote config switch. So your app, you publish your app early, then after you're confident that all your users have updated, you can flip that feature switch on for all of your users or some of your users and flip it off if it's having problems. So this is a great way to mitigate crashes, right? If you have a crash in your app, this is maybe the fastest way to fix it if you're just able to undo that feature that was turned on. Another part of Firebase Remote Config that's handy is you can do experimentation, so like A/B testing, and you can study the results in Google Analytics. So A/B testing is typically thought of as, what do your users prefer? Better like this or better like this? And let them decide. Let the performance of each one of those options decide. But you can apply A/B testing creatively to performance by using it to A/B test performance-related stuff. So say you're trying to measure the performance of a CDN. So you have all your images published to two different CDNs. You have a remote config switch that lets each app determine by configuration which CDN it should use. And then you can compare that in the dashboard to see which one is actually doing better. You could also compare cache configuration strategies. Now, there's probably a ton of things you can do here, but I'll focus on cache configuration strategies. So you can write some code that looks like this. In Firebase Remote Config, grab a configuration int called a cache size, and we'll just call that, maybe that's some sort of percent of memory that you want your cache to be. So say you wanted to test 10% versus 15%. How much better is 15 to 10? Like, we don't really know, but we're going to test it. So in your app, when it comes time to access the cache, what we're going to do is start a trace, grab an item out of the cache. If the item is not null, that means it's in the cache. Then we're going to increment a counter of cache hit size plus the cache size. And if it's not there, we're going to measure cache miss size. Now notice cache size is coming from remote config. So in some cases it might be 10, and in some cases it might be 15. So now you'll have these two counters in your trace. You can compare 10 to 15 and look and see, is it, does bumping up the amount of memory actually have an effect, like a positive effect in my app? So that's all I have. I've ended right on the 0 mark. So if anyone has any questions, please let me know. And thank you for your time. Yeah.
Okay, thanks. So I got a little lost when you were talking about initializing content providers, and it's possibly something to hook onto. Mm-hmm. Is that a thing you can do?
So, yes, let's talk about that. So, historically, Android developers have wanted a way to do something before anything else in their app. And in the past, it was all like application. You give an application subclass. Now, that works, but it has an interesting side effect of being initialized in every process within your app. So if you have a multi-process app, now you have two application objects. Content provider is special because it's only initialized in the main process of your app. So if you need a true singleton, like, if you don't want, say, like a write contention within your app, content provider is better. In fact, content provider is the way that Firebase initializes. Firebase uses content providers internally. Also, content providers have the advantage of participating in a manifest merge. So if you have a library that exports a content provider, it's automatically going to end up in the app that imports it. Application doesn't have that luxury, right? You have to declare it in your manifest. So now you're messing with your manifest to put this extra application object in there. And you can't have more than one application object. It has to be only one. So content provider has the advantage of having any library contribute something to the build that gets initialized at the time of startup. So that's why I prefer content providers. it does seem like an abuse of a content provider. It's not providing any content. It's just giving you a hook early on in the Android development, or early on in the boot, right?
What I'm trying to understand about it specifically is, like, how do I notify something else that content provider is going to, that I want it to be initialized? Is that something that I specify in the manifest?
The onCreate for a content provider is always going to execute. So because content provider participates in manifest merge, the manifest will get a content provider in it if it was part of a library, if it imported it from a library, which means its onCreate is going to happen every single time without fail. So you don't have to notify, you don't have to configure, it's very much automatic.
Okay. I have two more questions about this. I don't want to stop on other people. So, anybody else want to ask something? Sweet. Okay.
All right,
So
all you.
My first question is, do you have any keywords that I could use to follow up on this so I can check it out in more detail?
You mean the content provider thing?
Yeah, what you were just saying.
Yeah, so if you'll find some very lively discussion about content provider. All you have to do is search for like content provider, app init, and if you throw application in there too, you'll get like, and in fact, you'll see me participate in some of those as well, because one of the very first talks I did at I/O when Firebase was launched was on this issue of using content provider to init, and people, like there's this outrage, like it's an abuse of content provider, it's not providing content, like what's the deal with this, and you could debate back and forth, and like the use of application for init stuff, like that's always been frowned upon by the Android team, like they don't want people to do it, and they've always been very pessimistic about the need for a hook like this, whereas developers have proven over and over again, we need this hook. So we kind of just settled on content provider.
Subclass content provider and name it root provider.
you can call it whatever you want. Yeah.
So elsewhere in this conference, other folks have talked about adding objects to the application as a serious bummer, especially if they're static or singletons, for memory leaks. There was a really great talk about that last night as a source of zombie crashes. That leave the app alive in some state, but it could be safe. So is what you're suggesting safe from doing that if you're initializing other singletons within that content provider scope?
Yeah, well, if you're initializing singletons, I mean, the definition of a singleton is one instance, exactly one instance, alive for the entire duration of the app, right? I mean, that's a singleton. If you ever need to deallocate a singleton, then you probably don't want a singleton. You probably want an intelligent factory that decides when that object should be garbage collected or not. So my thought is you can always expect a singleton to be alive all the time. That's sort of like the implication. Call get instance, you will get an instance every single time.
So maybe just scoping it if possible, like if you're using DI, you can scope it in the module.
Yeah. So DI is effectively, to your point, singletons or maybe more, or scoped more, right? So you kind of have to decide for yourself. Yeah.
Okay.
It's been a long time since I've used Dagger, but I know that I've only ever used Dagger for singleton scoped objects, so I don't actually not too familiar with how that can work outside. But. Anyone? Oh, that wasn't a question. That was a stretch. Hey, oh, sorry. The guy behind you. Sorry.
What do you recommend for using Firebase database in espresso tests where you might not want to hit a network, but you don't want to re-implement Firebase database in memory?
That gets asked a lot. There's a project out there, a very old project, that attempted to be like an in-memory node-based Firebase implementation. That's kind of fallen by the wayside. And I don't remember if a Googler did that or if it was a third-party thing. I actually started to record a video series on unit testing with Firebase Real-Time Database. I'm of the impression that I would rather mock those objects. I would mock Real-Time Database and program its interactions so that you can, the Firebase API is relatively simple. Like, it's not that hard to mock. That said, if you want to simulate those actual interactions, if you would rather, say, accumulate data in something over time and not have to program that, yeah.
Use Monkey to do all this, record a bunch of posts to the database and then expect to get that back later.
Yeah. Well, at that point, are you writing a unit test or are you writing an integration test?
Yeah, I meant more espresso tests.
Yeah. Well, that's a good point. Yeah, so I didn't really talk about mocking objects within an espresso test. You're getting into an unusual and interesting hybrid, right? Where, like you said, you don't want to hit the network. You want your test to run as fast as possible. If you want to write that for us, that would be. We'll take that as a submission. It gets asked a lot, actually. If you want to talk about that later too, I'd be happy to know. So, oh, sorry, now you.
All right, so I've had to crash my program. I've caught it with, I guess, someplace down there where I caught the uncaught exceptions class. How do I get this I guess I send this to you guys at Firebase, and then how do I get it back to me?
Oh.
This is happening out in the field.
So the uncaught exception handler that's an Android general thing. That's not a Firebase specific thing.
Okay.
So that's Java and Android as a platform allow you to trap exceptions that popped fully off the stack. That's an uncaught exception.
Okay.
So when Firebase crash reporting, and really any crash reporting tool, that's their hook. So they'll add one of these uncaught exception handlers, add it as the default, and then wrap the prior into it just so that they're a good citizen, so that every crash reporter gets its turn to handle the crash. Now, if you're trying to log a custom crash, if you have, say you caught your own exception and you want to report it and have it show up in Firebase, Firebase has an API where you can report caught exceptions. So you just take the exception and dump it into an API.
Okay, that exception or, caught exception or the other one, how do I get that? How do I get that to, I guess I get it to Firebase and then I have to go to Firebase and look at it? Or
Yeah.
how do I get this information?
Yeah, so if you're using, in a general sense, crash reporting tools will collect all this information, aggregate it, and then show it in the dashboard. So Firebase crash reporting will actually coalesce similar looking issues or similar looking crashes into a single issue. So you know how like it is on Android devices, the stack trace for things could be slightly different between different versions of Android or different devices. And we'll take a look at that and like try to figure out is the root cause of a crash the same between a bunch of issues, and then they'll get coalesced and you'll go view that in the dashboard. So I'm not sure. Well, I can talk about Firebase crash reporting. What happens is it gets persisted in a local SQLite database. Then a service will kick in and try to take that data out of the SQLite database and make a connection to Firebase. And then when it's fully sent, we'll delete it out of the local database. So we're persisting it locally for some amount of time and then trying to send it as soon as possible.
So I just go to Firebase and you'll show me how to put that
You don't have to do any of that work. That all happens 100% completely automatically. So bare minimum integration for Firebase crash reporting is just add the compile dependency. That's it. And it'll just start working. You don't have to write any code.
Oh, okay.
Yeah.
All right. One more question here with systrace. I need to monitor. I would like to monitor memory usage. I think I've got something that is sucking up all my heat and running off the index, but I don't know. So will system trace will it tell me if I'm memory usage?
I don't. It's been a long time. I know that there is a memory monitor as part of the Android Studio tools. I don't know if that's technically.
Android Studio 3 has a really good memory monitor.
Okay, yeah, I've heard that there's been a lot of improvements in that lately. But yeah, there's basically a heap explorer, right, where you can look in. You can even like. Is that good for memory leaks nowadays? Can you find out where the object is that's holding the object that you would like, that you thought would be freed?
I believe so.
Okay,
At
yeah.
least as good as Matt was.
Mm-hmm. Okay.
So I need to run this in the 3.
Yeah.
Because I'm off in 2.
Yeah, 3 is still in like Canary, so.
Download a copy of it.
Oh, okay, okay.
Probably don't want to use production.
Well, it's up to you, right? A lot of Android developers want the new stuff. It's not uncommon. So, any other questions? Yeah.
Is there a limit to how many remote configurations I can have?
Yeah, I can't remember what that number is though.
Dozens, hundreds, thousands?
Hundreds.
Okay.
So I'm thinking for analytics, we'll give you 500 custom analytics events. I'm going to say it's on the same order of magnitude. So there's an interesting.
Use that for trunk-based development for the toggles. If I could just.
Yeah. So I'm trying to think. The funny thing is, I think, and this is a little interesting fact, that Firebase remote config was launched with no limits, and that was an oversight. And then they quickly had to like cobble and like, no, we can't just basically give away an unlimited key value store, right? We have to put some limit on it. There is a limit, but it's on the order of hundreds, I think.
And also, no, I forgot my other question.
Is it remote config or performance? So I'm always going to be at the Firebase table for this today, so definitely feel free to approach me. Or actually, Uday there, he works on Firebase performance monitoring, like he's one of the engineers on it, so I'm sure he would love to deep dive into that if anyone wants to.
Is there a Firebase database expert at the table?
You can ask me. I mean, I'll probably be able to answer your. I know a fair amount about most of Firebase, but mostly app quality and Cloud Functions.
Because the problem that we're having with Firebase database is it would be nice to use it as a store of a huge list of things that have multiple attributes, but we want to do just a full text search across multiple attributes.
Right. So yeah. So full text search is not a feature of Firebase real-time database. So for that, we typically recommend that you write to two places. You write to database and to a full text search engine, and then link them by some unique ID. Now, Cloud Functions makes that easier. So Cloud Functions, which was released at Cloud Next back in March, allows you to write database triggers. So every time you write to the database, you can have a bit of JavaScript code run, take that value, and then put it somewhere else. So basically, the client isn't responsible for writing to two places. The client's responsible for one place, and then the Cloud Function makes sure it gets distributed everywhere. So I'd take a look at that. I know that question gets asked a lot. People want to integrate into things like Solar or whatever full text search engine they want to use. So definitely try that. Anyone else? All right, cool. Thanks again.